Okay, today we're doing section 11.2, and it's about vectors. Okay, this time it's 3D vectors, and you did 2D vectors before, so this is going to be 3D. Okay, so let's just remember a basic vector, and then I'll give you some formulas on the right. So let's do example 1, see what you remember. So say you have a point. Okay, so say you have a point 1, 2, 7, and another point B, -3, 10, 4. Okay, and it says find vector AB, and then it also says find the absolute value. So find that in your mind. Find that in your mind, because if you can find that in the file folder in your brain where the 2D version lives, then you just add the third dimension to it. So it's pretty nice. So what do you think? My pens up here are different. It's kind of cool. These pens right here, let me show you where. My pens right here, they're different than they were before. They must have just changed, must have just been updated. It's very odd. It's kind of cool. I like the highlighter in the pen. Okay. So find AB. So how do you do that? Do you remember? Okay, now the way I think of it is I think of it as how do you get there? So how do I get from 1 to -3? So I need to go down 2. So I think of it like that. So -2, -4. I have to go down 4, sorry, not -2. I need to go down 4. Your teacher might have said subtract backwards. That also works. So I think of it as how do you get there or subtract backwards in an emergency. So then that would be 8. How do I get from 7 to 4? And that would be -3. And that is the x component, the y component, and the z component. So the only difference is you just have an extra component. And this is component form with the less than and the greater than sign. They kind of look like a less than or greater than sign. And then I'll write down the forms, but do you remember how you could write it with standard unit vector form? So I'm going to write this, and then we'll write an answer under. So standard unit vector form. Remember what that was? It was -4, and then the I put a little hat on it, but you can also make it bold, plus, or you can write it, I usually put the hat on it like the little caret, but you can also write it like this as a vector. And then we get just an extra letter. So let me draw it like the vectors, because I think most teachers don't draw it with the hats. That's what I learned when I was in college, but we all went to different schools. Actually, Miss Nicholas and I went to the same school. Okay, so let's see. There we go. What did the absolute value mean? Now, it could be either one. So I'm going to box both of these. This is called component form, this first one. Component form. Okay, so how do you find vector AB? With the absolute values on it. Do you remember what these stood for? Okay, now it is an absolute value, but what does it mean as it applies to a vector? It means magnitude. And then what was magnitude? Do you remember what magnitude was? Okay, so magnitude was this formula. Remember, you squared the x component, you squared the y component, and you squared the z component. Well, you didn't have a z back then, so you just squared the x component and the y component. So this would be 16 plus 64 plus 9. So that would be the square root of 89. And then try to simplify if you can, but I don't see a simplification, so that's it. So that would be the answer for the magnitude. We'll call this part A and part B. Okay, now some terminology. Let me point to some terminology for you. This point is called the initial point. That one's the one you're starting on. And this point is called the terminal point. Okay, so they sometimes use that in the textbook. There is a question that says to sketch the vector. So let's see what that looks like. Okay, not sure why this one turned out to be dark blue and it was light blue before, so that's kind of weird, but we'll see. I have no idea. Maybe the pressure. Maybe if I hold it down longer. Okay, so example 2. No reason for the change of colors. It says sketch a 3D vector. Okay, so what it actually had, I believe I saw in the book, is they have a vector, say u, vector u, and they give you a vector. So let's say -2, -7, +3. And actually, let's make that +2. And they say to sketch the vector, and then they say to sketch a vector that's 2u or a half a u or something like that. Okay, so they wanted you to sketch the original and something that is 2u. Okay, so if they ever want you to sketch it, you have to do it in the standard way. Oh, let me change to graph paper. Let's see if the graph paper thing changed. No, they look about the same. Okay, so let me use the eraser. Okay, I've been using this all year. This is how I teach in my class, but I just don't usually record the video. But I do use the same. I use this note thing so they can see it on my screen. Okay, so this is, do you remember what letter? The up and down is Z, right? So do you remember what the left and right is? Y, and then here, okay, coming forward is the X. Okay, so now when you're drawing a vector in 2D, so let me just draw a little 2D one. So if you're drawing a vector in 2D, you can actually start wherever you want. So you could say go right 2, go up 7, and then you would just draw the vector like this. Or most people, when they draw a vector, they start at 0, 0. So that's to the right 2, up 7, oh, down 7, huh? Okay, so let's do this one. So this is, you could start anywhere you wanted. You can go right 2, down 7. Let's move that up. Right 2, down 7. So in 2D, you could have drawn it like that, or you could draw it at the origin, right 2, down 7. So you can draw a vector. These are both u, actually. Okay, and you can draw them wherever you want. The standard place to draw them would be, though, is starting from the origin. Okay, so we'll do that in 3D as well. Okay, so you start here, and then it says to draw the vector to -7, 3. I would still do a trail. Okay, as I told you, I like to do the y and the z first. So the y is -7, so 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7. So -7, and then 3 for the z. Okay, so I'm going to do my little trail, my crumbs, then I'm here. And then it says I have to go, so I'm going to draw my line, little dash line that's the same, that's parallel to x. Okay, and I want to go forward. So this is forward 2. Okay, so I want to go forward 2, and this is left 7, and this is up 3. Okay, so the F stands for forward, and then you could also go backwards. So I want to go forward 2. Okay, so forward 2 would be along this line 2, and you just want to go like the equivalent of 2 squares, but it's not necessarily 2 squares because I'm slanted. Okay, so I just kind of draw 2 marks here. Okay, and that was 2 squares. Okay. Okay, so I followed my path. And then the answer vector, called the resultant vector, is from the initial point to the terminal point. Okay, so you draw a vector from the initial point to the terminal point, and then you draw an arrow. And this is 3D, so it's very hard to imagine. It's actually in, let me see if I can figure out what octant. Let's see, 1, 2, 3, 4. Positive z. I think that's the 4th octant. Okay, but that would be a different question. It doesn't ask that, so we don't have to worry about that. Okay, sketch 2u. Okay, so what would 2u look like? Well, 2u would be the same, and you could draw it either on top of it. Okay, you could either draw it on top of it, or you could start from somewhere else and do it the same angle. Okay, so here, and then I want to do 2 of them. Okay, the only thing is you have to make sure that you put your arrow at the end and your thing at the beginning. Okay, so that would be 2u, my 2 vector u. Okay, 2 vector u would be my highlighted one. Okay. Example 3. These are pretty nice. There's 2 types. So let me show you an example. I think you probably would be able to do these without an example. So they give you a u and they give you a v. Okay, and then they ask you to algebraically find z. Okay, so if they say z, vector z equals 2u minus 5z, 5 not z, 5v, how do you think you would find it? I don't even think you need my help for this one. So this would be what, 2, right? And then minus 5, and then v, 110, negative 4. Distribute the negative, right? So that would be what? Plus 5, negative 50, positive 20. And then over here, that would be 4, negative 6, 14. And then you add the x components, 9. You add the y components, negative 56. And you add the z components, 34. And then that would be the answer. That would be z. Vector z. You got to make sure you put, in the book they have it bold, but you have to put a little vector on the top to indicate that it is a vector. So we'll call this one A, and then B, so it says find z basically. And then it tells you what z is. Now there's another one though that says 2u, 2 vector u plus 3 vector z equals v. There's something like this, and it says find z. Okay, so let's see how we would do that one. So 2u would be 2, negative 3, 7. And you could do this with the ij's and k's if you prefer. Plus 3. Z is, I don't know, so I can't call that anything, right? I just have to call that z. And then equals v, which is 1, 10, negative 4. And then I want to solve for z. So how do I solve for z? What do you think? So try to solve this on your own. All right, try to solve it on your own, and then you can pause and then you can check. Okay, so 4, negative 6, 14, plus 3z. It's a little bizarre, but I think we can handle it. Okay, so now what do you think? How are you going to solve for z? How about subtract this vector from this side? Well, let's add the opposite. That's what I'm thinking. I'm thinking that if I add the opposite, then I already changed my signs. So I think that might be better, actually. All right, so negative 4. That'd be 0. I never actually showed my class how to do one of these. Usually we're low on time, so I figure that there's some that they can just throw their math out and figure out. But this is interesting. Okay, cool. Negative 3, 16, negative 18. And then what do you think? How do you find z? Can you divide? Do you feel like you could divide a vector by 3? Now you can't divide vectors, but you can divide by a scalar. A scalar is just a plain number. So then you're going to distribute negative 1, 16 thirds, and negative 6. Totally possible. I made an error here. Let's see if I can find it before you guys find it. So let's see. Okay, that looks right. That looks right. Let's see. I say it looks right, and then you're going to be like, Miss Nichols, you made an error. Okay, negative 18, negative 4. Okay, I think that's right. Unless I substituted the numbers in wrong, which is definitely possible too. So let's see. That one was right. Okay, I think I'm good on this one. Okay, so then that would be Z. Okay, so throw your math at it, and you'll be able to figure it out. Okay, magnitude of a vector in IJK form. Okay, so let's see. I wrote down a list of what you'd have to be doing in your homework. So it gave you something like 2i minus 3j plus 5k. And it said that this is equal to, say, w, vector w. And then it said find the magnitude of w. Or it used the notation. Remember, this is the same. Okay, the only thing with the IJK, and the reason why I wanted to bring it up, is when you do the magnitude, it's not 2i squared. Okay, this is not right. Okay, you can't do 2i squared because that I is not the imaginary number I. What that is, and what I always do, is I just like to write it in component form. So I would write it in component form. So the I, J, and the K are really just placeholders. Okay, so the magnitude is nicer from component form. So 4 plus 9 plus 25. You can just square them each. And then that's the square root of what? 13 plus 25, which is 38. Okay. And then can you simplify that to 19? Yeah, nothing comes up. So that's the magnitude. Okay. Example 5, dot product. Okay, so I don't know if you remember the dot product. Okay, so dot product in 2D, you had something like this. Okay, and then there was a dot. Okay, and then 4, 7, 10. So do you remember what the dot product was? Now we're going to have a new one. Okay, so we're going to have a new one. This one's called the dot product. It's also called a scalar product. It means your answer is going to turn out to be a number. Sometimes they also call it the inner product. Okay, so they call it a lot of different names. Okay, so what do you think? Do you remember? It's multiplication, so it does make sense to multiply. I'm going to show the work here, even though usually I wouldn't show this. I usually multiply like that in my head, so we'll make that one in a bubble. But what do you do once you multiply? It is not this. It is not that, because the answer is not a vector. So do you remember what it was? So that was at the beginning of this year. So this is good. This is practice, not the beginning of the year, the beginning of the semester. So this will be on the final. So plus, plus. Okay, so this right here is what you do for a dot product. Okay. So you get 8 plus 21 plus negative 60. And write the pluses. Write the pluses. I know it's negative 60 and you could write a minus, but you're trying to remember a formula. Okay, so let me put up this in a bubble. Let me put this in a bubble because I don't usually show that step. I'm just showing that step so you know what you're doing. So you don't have to show that step. You can go directly to this. Okay, so that's 29 minus 60, which is negative 31. And you don't take the absolute value of it or anything. It's just that. Okay, example 6. This is also from 2D. It said find the angle between the vectors. So do you remember what that was? Do you remember what angle between the vectors was? So you had a U, and you had a vector, then you had a V, and you had a vector. And how did you find the angle between the vectors? Remember? Now there is a formula, and you're going to want to write the formula out. You don't have to write the distance formula out and the midpoint formula out from section 11.1, but you do need to write the formula out for this one. Let's see. Just want to check. Did I write 11 too? Okay, I did. Okay, formula. So what was the formula? Do you remember? Do you remember? What was the formula? What was the formula? Now it's an angle, so it had to have a theta in it, but it wasn't theta equals. There was something else on this side with a theta. Do you remember what it was? So try to find it in your brain so you don't have to have two different parts in your brain where this formula lives. So you're trying to look for the formula in your brain. What was here? Okay, there's something over here on the left. And then on the right, there was a numerator and a denominator. Okay, so this was a cosine. And what was the rest? U, vector U, vector V. What did we do with them? Okay, the answer was the dot product. What did we put on the bottom? So try to remember it. What did we put on the bottom? Usually I wait until a student answers. So it's very strange to be asking and nobody's answering. What do you put on the bottom? Okay. You put this, and what's that mean? Remember, that means magnitude. So you put the magnitude on both. Okay, and then you're going to do theta equals the cosine inverse later. Okay, so we'll just put this. You do this later. Okay, definitely start it out as cosine theta, because sometimes they'll just ask you for cosine theta. Okay, so you don't want to start with theta equals. You want to start with cosine theta equals. Okay, and then there's actually multiple formulas. You're going to have 3D lines, and if you want the angle between them, Or if you have a plane and then you have another plane, say I have a plane and it's like slanted like this, and I want to know what the angle between the planes are, this angle right here, this angle right here, we're going to have a formula that's related to cosine in this chapter, in chapter 11. So, future. This is future. But right now we're just doing angle between vectors. Now the other two formulas are similar, but they have an absolute value. So let's put no absolute value, which sounds really stupid to write right now because you're like, why would I think that there might be an absolute value? Okay, you think there might be an absolute value because in the future, there's 2 more cosine formulas that you need to know, and both of them have an absolute value on the right side. Okay, so let's see. So let me make up one for you. So let's say 2, -1, 7, and 3, -2, 10. Okay, and it says, what is the angle between the vectors? Okay, so cosine theta, you write the formula, always write the formula. Okay, and then you're going to write your steps. Okay, you're going to write your steps. Half of the AP calculus exam, you have to show steps on. Okay, so usually I don't write the vectors there, I just square them. So square the 2, square the 1, square the 7. Square the 3, square the 4, square the 2, and square the 10. And what did I forget? What's this absolute value? I was about to put the formula, but I decided I don't usually put the formula. What do I put here? Magnitude is the square root. And then what's between these? It's a multiplication, but that's a regular multiplication, not a vector multiplication, because those are 2 scalars. So in the denominator, you have the square root of 54. And in this denominator, you have the square root of 113. And that's just an ordinary number, so that's not a strange multiplication. The top multiplication is actually a vector multiplication. It's called the dot product. Okay, and there's a new one we're going to learn today, which is called the cross product. Okay, so what do you do with the dot product? You multiply the x's, so 2 times 3, plus -1 times -2, plus 7 times 10. Okay, but like I said, I don't usually show this step right here. Okay, so let me just write this again. So usually I do not show that step. Usually I just do 6 plus 2 plus 70, and I just work it out. This is 678 over the square root of 54 times 113. I know on my test it says calculator ready because I don't let people use calculators, but then on some of the problems, but I don't know how it's going to turn out here during our time of coronavirus. So we'll see. Cosine theta. Hope you and your family are fine. Now the question said find the theta, so you do have to do theta equals. Okay, so theta equals, and you can be in radians or degrees, so check your calculator when you're doing it. Okay, and then I call this calculator ready form, but I don't know about your other teachers, so when they talk about how tests are going to be done in their class, you'll have to figure that out. I don't know if you're going to have a test on this section, but this is good for the final anyway. This is for homework 57. It's going to be good for the final because 2D vectors is on the final, and this stuff is in that chapter 6. So anyway, we did it. I don't know if I think it's 6 in your book. Okay, so calculator ready, or then you get an approximate answer on the calculator. Okay, so that is the angle between the vectors. Okay, and parallel, perpendicular, neither. What number is that one? Example 6. Okay, so this is example 7. Do you remember how to tell parallel, perpendicular? Do you remember how to tell parallel and perpendicular, neither? In vectors. Now, hopefully you use vectors when you're in chapter 6, because if you weren't using vectors in chapter 6, then you didn't get practice on this, and this will be brand new. So how do I tell if 2 vectors are parallel? So let's write a vector down. Well, let me write a vector down. 1, 2, 3. What would that be parallel to? That's just my abbreviation for parallel. It looks like 2 parallel lines. What would it be parallel to? Now it's parallel to any multiple. So it's parallel to 10, 20, 30. Or it's parallel to, you could divide by number. 1/5, 2/5, 3/5. So do you remember what the actual rule was, though? So parallel was U is parallel to V. I don't know why they use letters that are so similar. When U equals K times vector V. Or vice versa. You could do V equals K times vector U. And your job is to find K. So what do you multiply this one by to get that one? I would say you multiply by 10. So your K is 10. Or what would you multiply this one by? I would say you multiply by 1/5. So that would be your K. It is possible to be negative. So here, let me make one negative. Let me make this one negative. Let's put negatives on all of these. So it is possible to multiply by negative and it's still parallel. Perpendicular. Do you remember what perpendicular was in vectors? So try to find that in your mind. Okay, do you remember? It was something about the dot product. Do you remember what the dot product was supposed to be equal to if it was going to be perpendicular? 0. And then that means U is perpendicular to V. Okay, but they didn't call it perpendicular. So let me actually cross out perpendicular because they didn't call it perpendicular. Do you remember what the name was? It had a name. It started with an O. And then an R. And then a T. Do you remember? H. O. G-O-N-A-L. Remember? Orthogonal. So orthogonal basically means perpendicular. Okay, so if the dot product is 0, then they use the same abbreviation. So orthogonal looks like a perpendicular sign. So this symbol is also orthogonal. And then neither means just neither one is true. Okay, and we're going to do a little bit of perpendicular later, so we'll worry about that when we get to it. Okay, example 8. Oh, I had one in IJK form for this. I would say that if you ever have something in IJK form, so 2i plus 3j minus 4k, my suggestion is just change it to component form. It makes more sense. So there are some problems that said parallel, orthogonal, or neither, and they were in IJK form. Okay, and then we do need to discuss what IJ and K are, just specifically. This is as good a time for that as any. So let's just write standard unit vector in 3D. Okay. So standard unit vectors in 3D are vector I, vector j, and vector k. And your teacher probably is going to put a regular vector line on top of it. I don't know why I learned to do the one with the carrots on the top. So I don't want you to do something that shocks your teachers. Okay, so I is one movement in the x direction. J is one movement in the j direction. And k is one movement, one square in the z direction. Okay, so for I, if I want to go 1 in the x direction, then that's going to be a 1. And then what do I do for y and z? Well, I don't move them, so I'm going to make those both 0. The second one, I need 1 unit in the j direction. So where's the j? The y direction, which is in the middle. So that's 0, 1, and then none in the z direction. And k is 1 in the z direction, and then 0's here. And their lengths are 1. So that's why they're called unit vectors. Standard means we're just using the ones with the ones. Kind of looks like an augmented matrix, but it's not relevant to that. And then just 2D, just to remember. 2D, I was 1, 0. And then J was 0, 1. Basically, it just allows us to write it in component form and with the IJs in case. Okay, so that's it for 11.2, but I wanted to just, this homework assignment has just a couple questions from 11.3 on it, because you want to practice these new things called cross products before we apply them to problems. Okay, so you just want to mechanically be able to find a cross product. So 11.3 is about cross products and applications to cross products. Okay, so cross products. Okay, so if you have U dot V, what was that called? So this is the past. And by the past, I mean 11.2 and then also chapter 6. Okay, so what was the dot product? Okay, so do you remember what the dot product was? So you multiply, then you add. Then you multiply, then you add. Then you multiply, and then you get a number. Okay, that was your plan. Okay, so you multiply, 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 and then you add. Now, this is called a dot product. Okay, now we're going to do a cross product. So now there are two types of multiplications in vectors. So there's one that's a dot product and there's one that's a cross product. Now, if there's two multiplications, think of your life. What kind of multiplications did you have? When did you learn to use a dot? Didn't you learn to use a dot maybe in middle school, high school? What'd you use before the dot? So what if you were doing 2 times 3, but you didn't want to write it with a dot? Do you remember the old way, like if you were helping your like 3rd grade sister? What would that be? Wouldn't that be a times? Like that with the X? Okay. So now they mean something different. So in vectors, there's an application for dot products and for cross products. Okay, so this is called a cross product. It's also called a vector product because the answer is a vector. And I believe those are the only names I know for those. This one is totally different. It's super cool. So we're in vectors, and all of a sudden, somebody realized, hey, vectors need a determinant. Why would vectors need a determinant? Well, they're very similar. So the structure of mathematics, the underpinning, makes everything so similar. It's very interesting. So it's actually a determinant. So a cross product, the best way to find a cross product is to find the determinant of a specific matrix. Okay, so what you always do is you always put ijk here. Okay, and then I'll show you what you put for the rest. So I'm going to show you with 2 vectors. Okay, so let's give you u and v. Okay, so we'll put given u is the vector abc. And those are not coordinates. That's why I'm not calling it x1, y1, z1. And v is d, e, f. Okay, so for this one, you multiply the a and the d, the dot product. You multiply the b and the e, and then you multiply the c and the f. Oops, that's f. And then you multiply them and you add and you get a number. But for a cross product, you put the ABC here and the DEF, and the order matters. So you have to put the U in this row and the V is in this row. And then you do your determinant stuff. Remember the minus here, J, and you can use whichever vector marks that you want to use. I would use the hats if you're not in my class. I mean, I would use the regular vector thing if you're not in my class. Plus K times this. And then what did we put in there? Do you remember? So we crossed out the I, J, K column, and then we put in B, C, E, F. And then we crossed out the J column, right? And then hopefully you've done that homework. If you haven't done that homework, then you're going to be like, what in the world is she doing? Okay, A, C, D, F, and then the K. Right, let me erase that. So you erase that one, you cross out the K, and you cross out the column it is, and that's A, B, D, E. And then do you remember how you find the determinants, the 2 by 2? Yellow and blue, but what did you do with them? Do you remember what you did with them? You did I, and then you multiplied them, and then you subtracted. Okay, so you multiply and then you subtract. Minus J times AF minus CD plus K times AE minus BD. Okay, so you're always doing downs minus ups in these. Okay, and definitely want to do it by this method and not by the add 2 columns method, because then the like terms get all mixed up. So this is when I was talking about how this method would be better. Okay, and basically all you memorize is you memorize this. Okay, because you're going to already know how to find the determinant. Okay, and then you will get faster at cross products if you use it this way. The I, the negative J, and then the positive K, and then you do each determinant, because it turns out that the terms are like terms and you'll be able to do more in your head later. Okay, for the rest of chapter 11, when we need to use, we're going to utilize cross products. Okay, so let me show you an example. Let me see what example we're on. Example 7. So for this notes, we are on example 8. Okay, and this is our last one. Is that already example 8? Okay, so this is example 8. So this is our last one. So it says find 2, 1, 7 cross product. So they use an X instead of a dot. And 3, negative 4, 9. Okay, so what you're going to do is you're going to set up a determinant. Okay, and you're going to put IJK. It's really hard for me not to do those hats. So let me try to make sure, because I know some of you are not in my personal class. Here we go. And then 2, 1, 7, 3, negative 4, 9. Okay, so you set it up like that, and then you have to find it. So that's I, vector I, times a determinant, minus vector J. I really can't stop making those types there. Okay, then here, I'm sure my family thinks I'm weird. I'm like laughing to myself. Okay. So K. Okay, so what do we do? So we cross out this column and you put 1, 7, negative 4, 9. Okay, and then the next one you cross out this column and uncross out that column. And that's 2, 7, 3, 9. And you should be trying to do this on your own and pausing me. You'll learn much faster that way. Cross those out. And then 2, 1, 3, negative 4. Okay. That's actually the step that I often skip when I'm doing these. Definitely don't skip it at the beginning. But what I usually do is I usually go right for this step. Oh. Here, let me put all these things first so I don't screw it up. There we go. There we go. So usually I go directly to this step, like in the future, okay? Not the first time, but later you're going to want to do that. And then what I do is I look back instead of at the 1, 7, 4, 9 in that one, I look right here. Okay, I look at those. So I can do it from there. I can look at that and say, oh, that's 9 minus negative 28, right? Because you do down minus up. And then for J, okay, so for J, what am I doing? I'm not using this column, and then I can do my yellow minus my blue. Okay, so that's usually what I do, which is exactly what it says in the step above, but I start to do that instead. At the beginning, I wouldn't. At the beginning, I would write it out. So for this first assignment, 18 minus 21. But that's why it ends up getting faster than the column way, because I like the adding the 2 columns. That's actually my favorite way if they're numbers. But if they're IJs and Ks, I found out that this way is actually faster. So then I would do down minus up. Okay, but that's not going to make any sense if you take notes that look like that, because you're going to be like, where did she get those numbers? Okay, but you'll see how I got them from above. That's negative 8 minus 3. Okay, so I'm going to erase that. And then I'm just going to do the yellow minus blue, so you can remember. So that's down minus ups, down minus ups, oops, down minus ups. Okay, and then something really fascinating happens at the end. So this is 37i plus 3j, and put a little star here so you remember, minus 11k. Okay, so this is the answer. You could answer it in standard unit vector form, or you could answer it in component form. Okay, we could put or. So either one of these answers is okay. But something really cool happens, and then supposedly you're going to prove this in one of your homeworks. At least it used to be in our old schedule. I don't know if it's in our new schedule. You know, I didn't see it. I wonder if it comes up later. Maybe it comes up later in 11.3 on the next assignment that I haven't looked at yet. But what it is it's proving that this thing really works. So what do I mean by really works? There's a very interesting fact. Okay, the cross product is perpendicular to each of the vectors used. Let me show you that in format. This is U cross V, which is a vector, is perpendicular to U, and U cross V is also perpendicular to V. So you know how you've noticed that I definitely make errors. So I always check my cross products. Okay, so let me show you what I do. I take my answer, my 37, 3, negative 11, which I'm not sure if it's right because I definitely could have made an error, and maybe we'll find one right now. And I do the dot product by one of the originals. So the dot product, because I'm trying to see if it's perpendicular. Okay, and then I do take my answer here again, 37, 3, negative 11, and I dot it with my other one. Okay, so my 3, negative 4, 9. Now, what happens if I do these dot products? Supposedly, if everything went right, I'm supposed to get 0. Okay, so let me show you. If we multiply these two, okay, so multiply those two, and I get 74. Plus, I multiply the y components, and I get 3. And I multiply the z components, and I get negative 77. And then I kind of do math prayer. Like, please, please give me 0, because if it doesn't give me 0, I have to go back and find my error. Okay, which is 0. So I'm super happy. I'm like, oh, thank goodness. Thank goodness. Because it's so easy to make careless mistakes here. You make one multiplying error and you screw it up. Okay, 1 to 111 minus 12 minus 99. Oh, please, is negative 12 plus that? Negative 111. Yes. Oh, it worked. Okay, so that's the idea of what you do. So if you get 0, then you're happy. Okay? And you have to check it. Okay, so you must check. So I think it says confirm that it's orthogonal. Check or confirm orthogonal. And remember, orthogonal is really just vector's way of saying perpendicular. Okay, so they're slightly different. Technically, perpendicular, you're supposed to have things that cross, and vectors are movable, so they don't technically cross, so they needed to come up with a new name, but really it behaves like perpendicular. So if the vectors were made into lines, then those lines crossing would be perpendicular. So it's okay if you just are using perpendicular. Unless it says, are they orthogonal? And then you say, yes, they're orthogonal. Don't say, yes, they're perpendicular, because then you should answer like that. Okay, so that's the end of this video. And that takes us through the week. Yeah, that takes us through this week. So then we'll worry about next week, and we'll just keep going. Okay, so these are going to be important concepts, just mainly because it's also on your final with chapter 6. We don't know how we're doing finals and security and all that, so we'll see how we're going to do that. But it's also important for your future. Okay, you're going to see vectors in calculus in college. Okay, it's after AB. So we see it in BC calculus, but you also see it in the calculus chapters after BC calculus in college. And so if you've never seen it before and you don't know how to do like the basics, then you're going to be really suffering and stressed. And if you are taking HL, you definitely want to do it because it is on our HL exam. But we teach it again, but you want it to be review. And that's the whole thing of why you're learning during this break is we've already taught the most important things. Everything else that we're teaching, which is awesome. So you saw that in person with the teacher that you love. So the only thing that we're doing now is making sure all the extra topics that we always teach to give you an advantage, that you still have the opportunity to learn them. Okay, so do the homework, do the practice, upload it if you can so that your teachers are happy. And then once we start April 20th, points count again. Okay, so we'll have to figure out how all that works. We don't know how we're going to do tests, but we'll figure it out. Okay, so anyway, do what you can, learn a lot, and remember, you can play me on 1.5 if I'm too slow. Okay, but pause so you can try the question before you check if I got it right? Because I sometimes make mistakes. I love it when you guys find my errors in class, but it's kind of sad on YouTube because then the error is permanently there. Anyway, so make sure you do put the comment on the YouTube if you find that I made an error, and you can put it in Google Classroom first if you want me to confirm it. And then feel free to just put it on, don't give me a thumbs down. You guys, I'm trying my best. But I don't like to write the problems ahead of time because then I'm just quickly showing you what I did. I like for you to interact with the thinking process, and that's why I don't write all the answers ahead of time. So that's why sometimes I do make errors. Anyway, okay, so that's it. Talk to you later. Hope you're safe.